Previously on the AIXM 5 story, that was the Temple of AIXM. But who could help to understand all this? I would like to learn more about UML and how it is used for the logical data model of AIXM. Can you help me? Asked our AS guy, the IT expert. Of course, he replied, but I think we better start with some very basics. First, we must know that models play an important role in the IT world. In the software domain, a model serves the same purpose as, for example, blueprints do in the automotive industry for building cars. Now, UML is a commonly used standardized modeling language that helps to specify and document models of software systems, including their structure and design. The big advantage of UML is that you can visualize all this with specific diagrams. So in other words, it allows a graphical representation of a real-world process, such as the aeronautical information domain. The S guy tried to understand. Correct, the IT guy, after all, was impressed. UML defines a bunch of diagram types, of which AIXM mainly uses the class diagram. The main elements you will find on such a class diagram are features and objects, graphically represented by a rectangle. In UML, these rectangles are called class. Now, features describe real-world entities and are fundamental in AIXM. All instances of a feature have a common characteristic, such as an airport, a runway, or a navet have. Features and objects then have attributes, which are used to describe the characteristics. For example, an airport has a name, maybe an IKEA location indicator, a date when the magnetic variation was measured, and many other attributes. A runway has a length and a width, a navet a type, and so on. Features and objects have also relationships between each other, of certain multiplicity. For example, a runway is situated at 0 or 1 associated airport, but a navet may serve 0 or many airports as homing facility. Many in UML is expressed by an asterisk. In AIXM, relationships are modeled one-directional, represented by an arrow from the so-called source class to the target class. So the runway knows to which airport heliport it belongs, but the airport heliport does not know about his runways. Each relationship has also a name, such as is situated at. And every target class has a role, such as associated airport heliport. Relationships between features are called associations. The big difference between features and objects are that in the model objects cannot exist outside a feature. If the feature does not exist anymore, also its related objects cease to exist. For example, if a navet is decommissioned, there is no location of it anymore. For relationships between features and objects, compositions are used, indicating that the object is a part of the feature. Objects serve two purposes. First, they are needed in case an attribute has a multiplicity greater than 1, like in the case of served city. As an airport may serve more than one city, it cannot be an attribute of the airport heliport feature, but is modeled as object. Second, the elevated point attributes cannot be included in the navet feature, as these attributes are also used by other features, such as the airport heliport feature, to be able to express the position of the airport reference point. By the way, in UML, relationships and attributes are called properties. The value an attribute may carry is clearly defined by its data type. Therefore, each attribute of an AIXM feature has a named data type assigned, graphically separated from the attribute name by a double point. A data type may define a list of allowable values. In UML they call it a code list. For example, the attribute type of the navet feature has the assigned code list named code navet service type. This code list contains the allowable values that can be used for coding the type of an await. For example, ILS, NDB, or VORDME. A data type may also specify a certain pattern. A pattern may be further limited by range of values. For example, the data type for the ICAO location indicator of an airport heliport only allows uppercase alphabetic characters with the minimum and maximum amount of 4. This makes sense. It became clear to the AS guy. The ICAO code of an airport per definition is a 4-letter code, like Echo Golf Lima Lima for London Heathrow. Well, these are the most important key facts about the AIXM UML features, attributes and data types you should know, the IT guy concluded. If you want to learn more about AIXM, stay tuned and check out the next episodes of the AIXM 5 story.